Hi there, welcome back to the Dev All. I am Roman and this is the second part of our mini-series about domain modeling with options and maybes. I hope you liked the first part where we talked about null. If you haven't watched it, go there, watch it. I think it is a nice introduction into the whole topic. In this episode, we are going to talk about why options are actually not so good for modeling your domain and what are your choices are if you don't want to use them. So without further ado, los geht's. Alright, so the question is maybe an option for modeling your domain? And as you remember, hopefully, our domain is the domain of scuba diving courses. And there is one big company doing scuba diving courses, which is called PADI. And if you have a look at here, you have a couple of different certificates that you can actually do with PADI. And in here you have different kind of certificates. So for example, you have an adventure diver in here, and an adventure diver can have different specialties like deep diver or wreck diver. And you have an advanced open water diver, and you have different specialties in here like ice diver, whatever, scuba review, whatever. So let me show you a couple of problems that options have when they are used to modeling a domain and to build a business application. So the first problem is that an option actually bears no meaning in it. So what do I mean with this? So let's imagine that we have a function that says register for a course. So I'm a user and I want to register for some course. So I have a parameter for this function, which is this course, some kind of course. And this function returns an option of an int. So it returns an int, which is the course number or the registration number I get when I'm actually registering for a course. So, and when the registration was successful, the system is going to return me some int because it was successful. But it returns none when it was not successful. But now there is a problem with this because an option bears no meaning. So if you think of what could actually go wrong within my domain, within my application, why this is not possible. Of course, it could be possible because some database was not reachable, but there could also be some business reasons, right? Why this is not happening. For example, because the course would be full, or maybe I'm on a waiting list now. So, and these are cases where also the additional result type wouldn't really help, right? Because we don't really know why we don't get this. So maybe we can return a string in there in the error case, and with the option case or with the option type, we don't have any information at all. We only have none. So we have no clue what none means in our case. So this is like, again, very implicit semantics in here. We have some things like domain errors, which are not exceptions, but they're expected because they happen in the domain. So it's some kind of an error in my domain, and I don't really know about them. So this is really bad. Another thing where options might be the wrong tool to choose is if we have multiple options. So it is possible that we have multiple options in our system, and together, maybe even with booleans together, all the permutations of different sum and nones and true and falses can get our system into an illegal state. What do I mean with this? Well, let's have a look at this type here. It's another record, and it's a course registration workflow. So imagine we are building an actual registration website for such a scuba dive certificate course. And on the first page of this workflow, we need to choose a level, which is in this case an enum. And we choose a specialty like deep diver or wreck diver, as I've shown you in the diagram. And in the end, we can actually pick a specific course. This is some basic workflow for those kinds of things. But now, because it's a workflow, we have chosen an option type for each of those possibilities. Because on the first page, as I just said, we choose the level, then the specialty. And because on the first page, we don't have a specialty yet, it needs to be none because it's not there yet, right? So let's have a look at possible instantiation of those types. So the first one is, okay, we have a level, which is some adventure diver, and we have a specialty, which is some deep diver, and the course we are not have chosen on the last page of our workflow, the specific course, so it's none. So everything is perfect, right? But now let's have a look at a case that is not so perfect. So in this case, we have a level that is none, but we have a specialty that is some. So how can this be? We are in a workflow. So the first step should always be the level, and then the web page should actually show me all the specialties for a given level, for a level that I have chosen. So how can this actually be that we have a specialty without a level? This shouldn't be possible. So we need again some UI validation or something, but it's on the backend. And this data came through to the backend. So we have an illegal state here, right? So this is a pretty common error if we model like this with a lot of options. But there is also another kind of error that can occur. So let's have a look at this. It's perfectly fine at first glance. So we have a level set, and then we have a specialty set, and then we have no course set yet. So is this right? If I ask like this, of course it's not. So let's have a look at this thing here again. So if you have a look, the adventure diver has deep diver and wreck diver in it. And the ice diver is actually an advanced open water diver. So in here we have a level and we said, this is an adventure diver, right? So how can we then have chosen the ice diver as the specialty for this course? This shouldn't be possible. It should not be possible in our application to actually create this kind of instantiation of our record. So again, we need validation, we need tests, and so on and so forth. So this is not working at all. So again, in here we have implicit constraints coded and encoded into our type, and this is not really what we want to express actually. So the question is now, is maybe an option for modeling our domain? And I think it should not be one. So the first and most important thing for me is that an option bears no meaning. So we have no clue why the value is not there. It's just a hint that it might not be there. And furthermore, domain errors are not made explicit. So we have no clue what could go wrong in our domain and how to encode this. And the last thing I showed you is that multiple options and bools in combination might have hidden semantics in there. So again, the question is, maybe there is help? And yes, again, there is help. And the question is, the last time we had some problems with options in the first video, what did we do? We introduced a new type, result. So a new type that could encode a bit more information because it could encode why something went wrong, with some string encoding or some exception encoding. But what are we going to do now? Are we going to introduce another type? I'd say no. Let us introduce another class of types, which are algebraic data types. What are algebraic data types? It's a mouthful. It sounds really complicated, but in the end, it's not. So first and foremost, algebraic data types are composite types. So these are types that consist of other types. And there are two types of algebraic data types, which are sum types and which are product types. And the types we are talking in this video series about is the sum type. So what are sum type actually? Well, we have worked with them. Those are sum types. We have the option and we have the result. These are sum types, and I explain why they are called sum types in a second. So the nice thing about F# using them in F# is that they're pretty cheap and easy to create. So these are actually not types that are built into the language of F#. Those are also custom types that you can create on your own. So if you want to create the option type on your own, it looks like this. So instead of this pseudo syntax here, we have the type option of t, and we have two possibilities. We have either a sum of a t or we have a none. and the same goes for the result type. So we have a type result and it has two generic fields in there, and we have either the OK of t or the arrow of t arrow. And to create those things, we can do exactly what we have done in the last video. We say, for example, let size equals some wetsuit size. So we have in here a constructor function for this type, and we create a type option with the constructor sum. And later on with pattern matching, we can deconstruct everything and we always know what kind of instantiation we used to get these kinds of types. So the question is now, those are some types, and I said we are only talking about some types in this video series. So these are some types, and what are product types is the question then. Well, product types are the types that we're using all the times. They are like records, classes, structs, JavaScript objects, all these kinds of types. So why are they called some types and product types? Well, in the product types, the number of possibilities of type trainer is the ID, which is in this case a GUID, so it's infinite, times the name, times the age, times the wetsuit size. So what I mean with this, the why times, because we need to multiply all possibilities together to get the number of possible outcomes for a given trainer. Of course, if we have types like string and int and GUIDs, we have an infinite number of cases in there, but you always need to multiply each of them with the other possibility properties in those types. This is in contrast to those sum types, because in here we need not to multiply the sums and the nulls or the possibilities in here. We need to actually add them together. So in this case we have the number of possible none types, which is 1, and the number of possible sum types, which is in this case, if we have a string or an int, it's infinite, so it's infinite plus 1, but we need to just add them all together. Okay, this is about sum types and product types. Enough of this. So let's have a look how to actually fix those problems that we were talking about, right? So we said an option bears no meaning, but sometimes actually do. So let's have a look at this here. We have said that the return type is not clear. The none is not clear why this function did not actually register us for a course. So let's actually fix this. So instead of returning an option of int, what we are returning now is not an option of int, but a registration. So a registration is a new type that we can handcraft ourselves pretty easily. So in this case, we have a registration. And the registration consists of 3 possible cases. So the first one is accepted. And if it was accepted, it wraps some kind of confirmation number, which is an int in our case. And another thing could be that the course is just full. So it was rejected because the course is full. And the third possibility in our case is that we are in a waiting list and we are on spot number 10, for example. So this is a nice new case where we have 3 different custom cases defined by ourselves, similar to sum or none. And we can actually wrap different values in there. And because they are not generic, we don't need to mention them up here. So we just say this one wraps an int, this one also wraps an int. We could also wrap a string or an int or whatever we'd like to do in there. And the nice thing now is that domain errors, a domain error is just something that can happen in our domain and that we are actually expecting, are made explicit. So this is really nice. Another thing that some types allow us to do is to make illegal states unrepresentable. This is a notion that is used more and more, and I think it's a really important notion. So we were talking about illegal states and how there are some hidden semantics in some kind of ways, and some types actually give us the possibility to fix this. So let me just grab some coffee here. One sec. Okay, Let's fix those problems. So in this case, in the first case, we had the problem that we have chosen a specialty, but we didn't choose actually a level. And this should not be possible. So how can we fix this? Well, we could create a new sum type, and we call it course registration workflow. And this one has actually three instances, or three possible ways to create this. The first one is the choose party level. The second one is the choose specialty. But when we actually call this, we need to provide a party level to it. And in the last case, we use a choose course, but there we actually need to provide a party level and a specialty to it. So again, we have those custom cases, and we see that it's also possible to wrap two values, not just one value. And you see here that the types of those wrap values can be different than what I've just said. So when we then do this, we also have the party level and the specialty in here. And those are, for example, open water diver, adventure diver, and advanced open water diver. And the specialty could be deep diver, wreck diver, cavern diver, ice diver, what we have just seen in the diagram. So now the first thing is, the first step could be that we just say choose party level. And this doesn't take any parameters because they don't wrap any values. So we just have to choose party level in there, and it's perfectly fine. Could we now create a specialty, or say choose a specialty without providing a party level? No, we couldn't really do this because this choose specialty needs a party level. So we needed to actually provide this level to this function, or to this case, to create one. And the third one is the same. If we want to create a course, we need to provide it an adventure diver, deep diver, so a party level and a specialty. So this is really nice. So we had here, down here, those implicit constraints with the options that you can combine, but you can't really do it. You shouldn't really do it because there's some semantics, some constraints hidden in there. But up here, we have explicit constraints, and the compiler supports us, so it's not possible to make these illegal states, to get to those illegal states in your application. You don't need to write unit tests for this. It's just not possible anymore. And this is really nice. Okay, so let's fix the other error, if you remember it. So in this case here, we see that we have the choose course, and we give it an adventure diver and a deep diver. So we have the adventure diver as the party level, and the specialty was a deep diver. This is perfectly fine. But let's have a look at this one here, which is not perfectly fine anymore, right? Because we say we choose a course with an adventure diver and an ice diver. So this ice diver is actually belonging to the advanced open water diver. So it's not belonging to an adventure diver, and this shouldn't be possible because we said we wanted to try to make illegal states unrepresentable. So how can we actually fix this? Well, again, introduce another sum type and see how this will work out for us. So what we have done here is we have a party label, which is open water diver, etc. You have seen this list already. And we switch this to a party level with specialty. And this is not a lot of work in here. It's just a couple of new lines. So, and then we say, okay, the party level with specialty is the case is an open water diver, and the specialty also needs to be open water diver. So what do I mean with this? What do I mean? That we have here new types for the specialty. And for example, this specialty here, adventure diver, consists of deep diver and wreck diver. So if we want to create an instance now of this party level with specialty, and we want to say that it's an adventure diver, we need to use the adventure diver type in here. We can't put the advanced open water diver in here and put the ice diver. It's not working anymore. So if we actually do this, we need to change the type of our course registration workflow here. And we say, okay, when we've reached the choose course one, then a party level is not enough anymore. What we then need is a party level with a specialty. So when we're actually doing this, then we need to call it like this. It's not a tuple in here anymore because it's just one parameter. And we say, okay, we say choose course, which needs a PuTTY level with a speciality. These are those here. And we choose the adventure diver. And then we need to instantiate it with the case of the adventure diver type. And in this case, we use the ice diver. So this is not compiling. We don't need to write a unit test anymore because we can't compile this code. It's just not working. I can't put this in there. And this is really nice because those types just don't mix. But when we actually changing this and say, okay, now we have an adventure diver that takes a rec diver, which is a specialty of those adventure divers, everything compiles and we are pretty happy. So again, we move from implicit constraints down here because it has again some implicit semantics, some things encoded that we can't explicitly see, which bears the possibility for a lot of problems, and we need a lot of unit tests for this. We moved this to something that has explicit constraints, which isn't much more work, much more to write. It's very clear and you can actually understand this, and the compiler helps you a lot with this. All right, this marks the end of the second episode of this small mini series about domain modeling with options and maybes. I hope you liked it that far. If yes, give me a like, give me a subscribe, ask me anything you'd like in the comments. The next episode will be a small example how to bring all of this together, in that case on the front end. Thank you so much for staying with me for so long. Hope to see you folks around. Bye bye. Bis bald. Ciao.